Number 3, determine convergence or divergence of this series, the sum from n is equal to 2 to infinity, from n factorial times 2n factorial times 5 to the n, all of that divided by 3n factorial. So we have to figure out what test to use here. And so I see two main features. One feature is I see exclamation points, I see factorials, and I also see a constant raised to the nth power. So that very much says that we should think about using the ratio test. The ratio test is great for both of those cases, factorials and for constants raised to the nth power. So I'll have to call all of this here a sub n. And so we'll do the limit as n goes to infinity of the ratio of a sub n plus 1 divided by a sub n, the absolute value of that. So first I'm going to calculate out this ratio and then simplify as much as I can, and then I will take the limit of it. Okay, how to tackle this? Okay, so for a sub n plus 1, everywhere I see an n, I replace it with an n plus 1. So n plus 1 factorial times 2 times n plus 1 factorial times 5 to the n plus 1 divided by 3 times n plus 1 factorial. All of that over n factorial times 2n factorial times 5 to the n divided by 3n factorial. Now, before I had absolute value bars, I'm just going to drop the absolute value bars because everything here in sight is positive. Okay, so next thing I'm going to do, I'm going to rearrange this. I'm going to group the terms that look alike together. Let me come down here, give myself plenty of room. Okay, so I have an n plus 1 factorial divided by an n factorial. 2 times n plus 1, that's 2n plus 2 factorial divided by 2n factorial. I have a 5 to the n plus 1 divided by 5 to the n. I have this 3n factorial gets flipped upstairs. And there's a 3, so 3 times n plus 1 is 3n plus 3 factorial, that's downstairs. Okay, so I have to simplify this as much as I can. And the key trick that I'm going to do here is for each of these factorials, I can rewrite them in terms of the other factorial. What do I mean by that? So n plus 1 factorial, I can rewrite that as n plus 1 times n factorial. And so now I'm going to be able to cancel out those n factorials. 2n plus 2 factorial, I can spin off factors of 2n plus 2 times 2n plus 1, all of that times 2n factorial. 5 to the n plus 1 divided by 5 to the n. So those cancel and we're just left with times 5. So that's real nice. And then finally, 3n factorial. What do we do with 3n plus 3 factorial? We can spin off factors of 3n plus 3 times 3n plus 2 and 3n plus 1. And all of that times 3n factorial. Okay, so let me do some cancellations. What cancels here? Those cancel, and those cancel. So take all of this. Let's move it to the next piece of paper. And so we end up with the ratio is 5 times n plus 1 times 2n plus 2 times 2n plus 1. And downstairs, we have 3n plus 3, 3n plus 2, and 3n plus 1. Okay, so this right here is the ratio of an plus 1 divided by a sub n. And so the ratio test now tells us that we have to think about, so rho is the limit as n goes to infinity of this ratio right here. Okay, so at this point, we just have to tackle this. I think we can simplify just a little bit. 3n plus 3 is 3 times n plus 1. So this becomes limit as n goes to infinity of 5 times 2n plus 2 times 2n plus 1 divided by 3n plus 2 times 3n plus 1. And so we have to determine this limit. There's several different ways that we can do it. One way is to move that 5/3 out in front and then break these up separately. 2n plus 2 divided by 3n plus 2 times the limit as n goes to infinity of 2n plus 1 divided by 3n plus 1. And it's pretty easy to see that each of these two individual limits is 2/3. So what does that leave us with? 5/3 times 2/3 times 2/3. And this multiplies together. 5 times 2 times 2 is 20. 3 cubed is 27. And that is strictly less than 1. So the ratio test, by the ratio test, we know our original series, it converges. If there were negative values of what we could say absolutely converges, we might as well just say converges here. So this converges. Okay, quick recap of the question. Factorials and constant raised to the nth power tell us ratio test. So we have to write out the ratio. Do lots of simplification. The key trick on the simplification is simplifying the different factorials, like 3n plus 3 factor is 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial. And then simplifying this limit at the end. There's lots of ways to do it. Look, you could have used L'Hopital's rule. You could have used, just look at the coefficient of the highest degree terms in the top and bottom. Lots of ways to do it to get to 20 over 27. That's the one. So ratio test tells us that this converges.